So chapter 7, day 2 topic. So we're going to continue with a little bit of ideas from scatter plots, but today we're going to kind of try to interpret our scatter plots and what we call correlation. And so when we're done today, we want to be able to interpret our scatter plots with two variables using something called FODS. Now that's obviously an acronym. And then we want to be able to describe the correlation coefficient is something that we're also going to talk about today. Okay, so if we go to this page, so FODS stands for form, outlier, direction, and strength, okay? And so form, basically we are gonna have, there we go, there's our graph. Linear, which basically means it kind of looks like it's in a line, or nonlinear, which basically means you're gonna see some kind of a curve or it's kind of spaced out basically. So we're going to have linear and nonlinear. Outlier. And so an outlier, kind of think, if you see the blue dots here, we have a bunch of dots that are kind of together, so go ahead and put those on your graph. And then we have a single dot that's kind of out far away from the rest of the dots. That's going to be our outlier. And so it just means that we're outside the normal pattern. It affects linear equations. It affects our correlation coefficient if we have an outlier. Then we're going to address direction. We either have a positive direction, which just means as I look from left to right, it's going up, or we're going to have a negative direction. So as we look at it, it's going to be going down from left to right. And then what is the strength of our relationship? So a strong relationship would mean the dots are very tight and close together. A weak relationship would mean that the dots are very spread out from each other, okay? Now, if you need to, go ahead and hit pause. If you need to kind of finish up some graphs or whatever, go ahead and do that, okay? And so I'll kind of let you see the different ones. So strength, direction, outlier, form. So form, outlier, direction, strength, okay? When you're ready, we will flip the page. All right, so we want to get practice at describing data basically, okay? All right, so this is what the FODS sentence is going to look like. And so every time we're basically going to kind of rewrite this same sentence with information filled in. And so we're going to be saying there is a blank, 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 blank relationship between blank and blank with blank outliers, okay? So let's go take a look at our data. So we've got company ABC here, and over on the bottom we have number of hours worked and the amount of dollars or amount earned in dollars, okay? And so when I look at this, first thing I decide is how strong is this relationship? And this is strong. The dots are very tight together. So there is a strong positive, because it's going up, linear relationship between the hours worked, which is the explanatory variable, that's the one that's going to be down here on the bottom, and the amount earned, which is your response variable, which is going to be over here on the y-axis, with no or zero outliers. Okay, so go ahead, make sure you're filling those in your notes. There is a strong positive linear relationship between hours worked and amount earned with zero outliers. Okay. When you're ready, we are going to go to the next page. If you have to hit pause to fill this in, go right ahead. Okay, so we want to get practice at basically writing these sentences for ourselves. So I'm going to kind of be going back and forth in my head to what we had on the previous page. Okay, let me give myself a little room here. All right, so the first one we're going to talk about is Best Buy here. So that's the company that we're looking at. And we are analyzing the number of TVs and the price per TV. Okay. All right, so when I look at this, and so every sentence starts out the same. There is, and then the first thing we're going to talk about is this strong or is this weak? Okay, and so these dots are very tight together in this line. So there is a strong, and then I need to do the direction. This thing is going downward, so that means it's a negative, kind of like think like slope that we talk about back in linear algebra. It's like a negative slope. So there is a strong, let me put A in here. There is a strong negative, and then it's in a line, so linear relationship between the number of TVs and the price per TV. With, and then we got to look for outliers. 0 outliers, okay? So basically the decisions we have to make is it strong or weak? Is it positive or negative? Is it a linear or nonlinear? Then the explanatory variable, the response to that explanatory variable, and then how many outliers. The rest of the sentence will look exactly the same all the time, okay? Next one, so we got Cooley Ice Cream Shop, and we are talking about how many customers do we have and probably what's the temperature outside, okay? And so we're going to discuss FODs for that. What is our relationship, basically, okay? So there is a, and so when I look at this one now, the dots are a little bit more spread out, okay? And so I'm going to put weak. It's not horribly weak, but it's a little bit weaker. Then, is it positive or negative? Are the dots going up or the dots going down? So the dots are going up. So this is a positive. And then they're still relatively in a line. So I'm going to call it a linear relationship. Between, and then we got to discuss the explanatory number of customers and, so what do the customers get? Okay, the temperature with 0 outliers. Okay. All right. When you're ready, let's go to the next page. So that's basically doing FODs. You just got to repeat that sentence and fill in the basic things. So when you get to that chunk on your homework, have this page available where we filled everything in, because it basically tells you what do we need to fill in. And so if you have that available, you repeat it a few times, it actually becomes pretty easy to do the sentences. All right, correlation coefficient. Okay, so correlation coefficient, we use the letter R to describe the correlation coefficient. And so what the correlation coefficient does is it describes the direction that our data is going and how strong of a linear relationship that we have between the two quantitative variables. And so correlation, the correlation coefficient, is basically a measurement of association. How strongly are these two data points associated with each other? Okay. So the correlation describes the direction. So is it going up or is it going down? And the strength, so how closely are the dots to each other? Of a linear, it's always linear, relationship between two quantitative variables. It's basically a measure of association. How strongly associated are these two pieces of information with each other? Okay. All right, so 6 things to know about correlation. If I have a positive number, okay, so when I see it, it's actually going to be a number, not an R. If I have a positive number, that indicates a positive association. And so what a positive association means is as one quantity gets bigger, the other quantity gets bigger. So yesterday we talked about snowfall and shoveling time. As the amount of snowfall went up, the shoveling time should go up. That's a positive correlation. Okay? A negative number indicates a negative association. So I'll give you a quick example of something that would be that in a second. So a negative number would be a negative association. So a negative association goes in the opposite direction. So we'll talk about something that would be easy to kind of think in your head. Number of days you skip class versus your grade in class. The more days you skip, the lower your grade percent is going to be. So that would be a negative association. The more days you skip, the farther down your grade would go. Okay? Number 2, R values are always between, there we go, got to get it in the middle here. -1 and, hopefully I can find it somewhere, there we go, +1. Okay? So the R value is always between -1 and +1. Okay? If you have a -1 or a +1, that means you have an absolutely perfect association. So in real life, it's actually super, super hard to get an exact +1 when we're trying to find a correlation between two things. So this one, what we're looking for here is that R, I gotta find it, there we go. R does not change when the units change. So if you have, for some reason, you got to switch from inches to feet or centimeters to inches, whatever you got to change. If you change the units on one of your measurements, the R value still stays the same between the two different measurements. Okay? When we're measuring R values, the explanatory and the response variables don't really matter. And so when we're trying to come up with these R values, it doesn't matter which one we call the X and the Y, because the data is just going to try to form a relationship between these numbers. And so it won't really matter which one is the X and the Y. They can basically flip-flop. And you'll kind of see tomorrow when we get into kind of finding the R value exactly, you'll see what I mean by that it's not a big deal. All right, and 6, having board issues today. Whoop, hang on, here we go. This is actually 5 here. It's only used for linear associations. and the R value is strongly affected by outliers. Okay? So I'm going to kind of go over these again because I know it's a little goofy here. So this one should be down here a little bit. Something happened with our points. We got off a little bit. All right, so a positive R value means that we have a positive association. As one gets bigger, the other gets bigger. A negative R value indicates a negative association. So as one of the things gets larger, the other gets smaller. All R values have to be between -1 and +1. The R value does not change when I change from centimeters to inches or any kind of unit change, basically. The explanatory and the response variable, so my X and my Y, can basically flip-flop and I'm still going to get the same R value. We only use R values when we talk about linear associations, and it's strongly affected by just a few outliers. So if I have an outlier in my group or a piece of information that's way far away from the rest, it has a big impact on our outlier, on our R value, from being a strong association to more of a medium association. Okay. All right, you do not have this in your notes. This is just an example so you can kind of see what it means. So along the line here is basically an example or a screenshot of what do these graphs look like. So if I have a strong negative association, so that's -0.99, which is super strong because it's almost -1. Notice how tight the dots are and that they're going down. Now I get to -0.7. The dots are a little bit more spread out, but I can still tell they're going down. -0.3, it's getting harder to tell which way they go, and they're really spread out from each other. Like, it's really hard to tell that it goes this way, but that does a little bit. 0, you absolutely can't tell. Is it going up? Is it going down? The dots are all over the place. Hard to know. Now this one, I can tell it's going up, and they're a little bit tighter together. So now I'm up to 0.5. And then this one, I'm really much tighter together. For sure I'm going up, so I'm getting a positive 0.9. Okay? And so those are just some examples of what the dot association might look like when we get a correlation coefficient. Okay? All right, so it says describe the correlation and then estimate the R value. Okay, so describe the association. So when they're just saying, is it strong? Is it weak? Is it positive? Is it negative, etc.? Okay, or is it 0 basically? All right, so when I look at these, this first one, they are perfectly in a row. This is a strong positive association. These two things are highly associated with each other. Okay? Next one, I think they're still going up, but it's really hard to tell. And so I'm going to call this one a weak positive association. Next one, I can't tell. They're all over the place. That's basically 0. It's hard to tell, is it positive, is it negative, does it even have an association together, okay? D, going down for sure, so this is a strong, and it would be negative. This one I can still tell it's going down, but it's much weaker, so this is a weak negative. And then this one, I don't even know what this is. You can't even tell. That's going to be a 0 again. Okay? All right, so that's the first chunk. Then they wanted me to estimate an R value. And so basically in that, right underneath basically, I'm going to write down just an estimate. Okay? So the first one, it is perfectly straight. I'm going to say the R value is 1. That's a perfectly straight line. That's going to give us an R value of 1 or 0.99, real close. Next one, it's much weaker, and so my number's not hidden here, so I called it 0.3. So this is an R value of 0.3. This one, I'm going to give it, since I called it 0, I'm going to say that it's a 0, or it's real close to 0 if I can get the number. Negative 0.2 I put, I think. Okay, and that's just a guess. That's all of these are just guesses. Until we kind of get into the computer stuff of it tomorrow, you're just going to be estimating. This one's negative, but it's stronger. So I'm going to say about a negative 0.8. Next one is weak negative, so I know that I'm going to have a negative number, so negative 0.5 I put. And then this one, 0. Okay. This one up here, maybe I should have described it. Instead of saying 0, I'm going to put close to 0. Okay. So these are all, when I'm doing these numbers, there's not an exact way right now. These are just estimates. So don't freak out if you know if I had you guess and your number was a little bit off from mine, that's going to happen. Okay. And so there's kind of a line of it. All right. This page. So this page is a little bit easier to do. So it says determine if the association is positive or negative, then indicate if the correlation coefficient is going to be closer to -1, closer to 0, or closer to +1. So I'm not trying to guess what it is. I'm just trying to say what is it close to, okay? And so that's all about how close do I think the dots are to each other. Okay, so let's look at our pictures. So first thing I see on the first picture, it's going down. So I know it's going to have a negative correlation, okay? And then I got to decide, are these dots kind of tight together or are they way spread out from each other? And so kind of think, if I drew a line through them, they're pretty close to that line. I'm going to say that that's a stronger correlation. So I'm going to say that's closer to -1. It's not exactly -1. It's just saying that's the closest out of my 3 options, okay? Number 6. Most of the dots are pretty close to that line. It's going up. So that's a +1 correlation. Okay. Now, number 7, I'm nervous about. Most of these dots are really super close. And so this thing would have, like, if I did the actual R value on it, it looks like it should be like 0.8, 0.9, 0.99, something really tight, right? But we have an outlier. And outliers can make it a little goofy. And so I'm still going to say that it's close to 1, but it's probably more like 0.55, 0.6, just because of that one outlier. Outliers can kind of blow up the association value and that correlation coefficient value, okay? Next one, so my line would go through here. So I think it's positive, but those are pretty spread out from each other. And so it might be more like a 0.3, 0.2. Well, technically 0.3 and 0.2 are closer to 0 than they are to 1. So I'm going to say that that's closer to 0. Okay? All right, next page. All right, so for 1 through 4, the calories and total fat in grams listed in the chart below are based on a burger with a bun, condiments, and cheese. Okay, so here's the first thing I would like you to do. I want you to stop the video after I finish talking here. I want you to take and put these over on the graph. And I've already got the numbers on the graph so you can kind of tell what's what. So make sure you're paying attention and paying attention to numbers. And so I want you to go and make a scatter plot, put a title on it, label the axes, and then put your points on there. Okay, so pause the video, do the scatter plot, put the points on, put the labels on any of the axes that we need, and put a title on it. Okay. All right. So first thing I'm going to do is I'm going to put a title on it. And so I'm going to call it total fat versus calories. And then when I look at the numbers on here, I can tell that down here on the bottom, just the way they've labeled the axis, this is the fat and it's measured in grams. And then over here, these are calories, okay? So you should have that, and then basically these are kind of reverse ordered pairs. And so really this would be 12,300 is the way I would graph it, okay? And so I'm hoping that you already have the graph done. And so I have all of these points on there for all these different types of burgers. Then they want us to ask or answer some questions about it, okay? So the first thing they want to know is which one do you think is the explanatory variable? So do you think calories explain the fat or that the fat explains the calories? So basically think in your head, which causes which? Do the number of calories cause how much fat is in my hamburger? Or does the amount of fat in my hamburger cause the calories that I'm going to eat, basically, okay? And I'm hoping that we realize that fat causes the calories, okay? And so over in this line, I'm going to say fat explains calories. Therefore, fat is the explanatory variable and calories is the response variable. Okay, so we plotted the ordered pair already. Step 3, describe the relationship using a complete sentence. Okay, and so when they say describe the relationship on a scatter plot, they're asking us to do that FODS sentence that we had. Okay, and so I'm going to put there is, and then we have to look at our data. Is it strong? Is it weak? To me, this looks very strong. If you kind of think in your head, I have to write a line, draw a line between here. All of those dots are pretty tight to that line. And so there is a strong, and then you got to say what type, is it positive or negative? And so if you look at our line, it's going up. So positive, linear relationship between fat, because that's the explanatory, and calories, because that's the response, with, and then we have to look for outliers. So if I go look at my graph, do we see any dot that's far away from the rest? And so sometimes people think this dot up here maybe is far from the rest, but it's not. It's right in line with the rest of them. An outlier would be if I have a dot like way down here somewhere, okay? That would be considered an outlier. And so in this case, we're going to say with 0 outliers. Okay, and then step 4, are there any obvious outliers in the scatter plot? No, there are not. Okay, all right, so today you have day 2's homework. It should be on Schoology. Go ahead and get that taken care of, please.